Hi, this is Homework Helpers review for the third quarter final. This review video is about electrochemistry. Remember, electrochemistry is using redox reactions in order to make energy or create chemical energy. All right, so two different types of cells. There's a voltaic cell that looks like this. I know I have two half cells here. All right, a voltaic cell takes chemical energy and converts it to electrical energy. These are the things you need to know. It's a spontaneous reaction, and the anode is always oxidation, and the anode in a voltaic cell is negative. The cathode is always reduction, and the cathode is positive. These charges are going to switch in an electrolytic cell, so I'll show you when we get to that. Here are some acronyms you can remember. Anox, anode oxidation, red cat, reduction cathode. And in a electrochemical cell, the cathode gains mass. So red cat gets fat. Fat is one way to remember that. So the electrons in an electrolytic cell go through a wire. They always travel from the anode where they lose electrons to the cathode where they gain electrons. This is a salt bridge in the middle. The salt bridge allows for ions to migrate, and this helps adjust the charge so it's not charge isn't concentrated in one cell. So let's label all the parts of this. I'm going to pick two elements here. I'm going to make this electrode iron and this electrode barium. Okay. Now the first thing I want to do, and actually it says lithium and copper. So actually let's make this guy lithium, and this guy copper. So lithium and copper. LiCu. I want to figure out which one is the anode. So I'm going to go on to table T. Copper is here, and lithium is up at the top. The more reactive metal, so more reactive, is the anode. So this guy, lithium, is the anode. It's going to be oxidation, and it's going to be negative. This guy is the cathode. It's going to be reduction, and it's negative. Okay? This is my salt bridge in the middle, and this is my wire. That's where electricity is going to travel through the wire. So we're always going to have electrons travel from the anode to the cathode. So if I have to draw an arrow on here, electron flow, it's going to flow from the anode through the light to the cathode. Okay? Let's look at electrolytic cells. Electrolytic cells are an example would be electroplating. They use electrical energy to make a chemical reaction happen. It uses an external power source to provide energy for a non-spontaneous reaction. Now in this case, the anode is still oxidation, but now it's a positive charge. The cathode is still reduction, but now it's a negative charge. The electrons move through the wire. They're still going from anode to cathode. That doesn't change. Okay, if I'm doing electroplating, I always remember my little story of forking the cat, okay, or spooning the cat. The item that's you're going to be plating, the fork or the spoon, is always located at the cathode because I'm going to be adding mass to that when I add the metal, the less reactive metal, to the outside. So the electroplating always starts at the cathode. Fork the cat. So that guy's the cathode. This guy would be the anode. This is my external power source. The purpose of that power source is to provide energy for the reaction. Okay. What's going to happen is silver is going to become silver plus 1 by losing an electron. And then that silver plus 1 is going to gain electron over here at the cathode and become silver 0 again, except now it's attached to the spoon. Okay? So we're going to take a less reactive metal and plate it with a more reactive metal to protect it on the outside. And that's electrolysis. Make sure you understand the difference between electrochemistry, a voltaic cell, and an electrolytic cell. I hope this was helpful.